Okay, so yesterday we talked about ionic bonding, which is a loss and a gain of electrons, and then they're held together by an electrostatic attraction. Today we're going to talk about covalent compounds. And covalent compounds, the atoms share electrons. So that's one of our major differences here. The second difference is what is in a covalent compound. So they're a nonmetal plus a nonmetal. So in yesterday's type of bonding, ionic, the metal lost an electron to become positive and the nonmetal gained an electron to become negative, and then that electrostatic attraction held them together. In a covalent bond, we're not creating ions. So there are a couple other interactions at play here. So there are three types of electrostatic interactions. And electrostatic just means that they're between charged compounds or charged parts. So there's the attraction between the electrons and the nuclei, that plus and minus attraction that we've talked a lot about. There's a repulsion between the electrons, which we've also talked about. But there's a new type of repulsion between the nuclei. So we've got our positive repulsion here. So it's kind of a balance between the nuclei getting close enough and then the electrons being attracted, but also not getting too close to each other. Covalent bonding does happen. So what that means is that the attractive forces of the electrons in the nuclei outweigh the repulsions, and the atoms are able to stick together. When I talk about covalent bonding, I like to think about holding hands. So in an ionic compound, you give away your electrons, but in a covalent compound, you share. So you get to hold on to your hand, someone else gets to, but you also get to hold on to your friend's hand. So you're attached because you're holding hands, but you don't have to chop off your hand and give it to your partner. So when we do covalent bonding, we can also symbolize it using the Lewis symbols or the dot diagrams. We have to do it slightly different than we did with the ionic though. So yesterday with ionic, we used arrows to show that the electrons are moving from one atom to another. But like we just said, they share. So hydrogen in this case gets to hold on to its electrons and oxygen gets to hold on to his. So what happens is they get really close to each other and they hold hands basically. The way that we're going to show that is with this circle here. So inside this circle is a set of electrons. And with that set of electrons, oxygen now has 8 and hydrogen has 2, which it's happy with. So let's walk through one of these. So the first thing is going to be to get the formula. So carbon tetrahydride is carbon with 4 hydrogen. In the center atom is going to be the most electronegative. So in this case, it's going to be carbon. And we're going to draw carbon with its 4 valence electrons. 1, 2, 3, 4. Next, we're going to place the other atoms around it. So I've got 4 hydrogen and 4 spots for bonds. So I'm going to draw on my 4 hydrogen. 1, 2, 3, 4. And then our third step is to circle shared electrons. So I'm going to circle between this hydrogen and carbon, this hydrogen and carbon, this hydrogen and carbon, and then this hydrogen and carbon here. So if I picked that center carbon up, the hydrogen would follow with it. We want to make sure that everything is connected and that there are no lone electrons left. And then we'll kind of count it up. So each circle is 2 electrons. So carbon has 1, 2, 3, 4 circles around it, which is 8 electrons. And each hydrogen has 1 circle attached to it. And hydrogen is happy with 2 electrons. It's such a small atom. Okay, so let's follow this process one more time together, and then you guys are going to practice it. So we are going to do sulfur monoxide. So sulfur is S, and then monoxide, that mono tells me that there's 1 oxygen. We're supposed to choose the most electronegative atom to put in the center, but there's only 2 elements, so we're just going to put them next to each other. Sulfur has 6 valence electrons. 1, 2, 3, 4, 5, 6. And in the last one, we had some like kind of crazy loops. So I'm going to kind of move around where I do my dots just to make this look a little bit neater. This is an S, not a 5. And then we're going to do 1, 2, 3, 4, 5, 6 on our oxygen as well. Okay, so what we're going to do is connect them with a circle to show sharing electrons. So I'm going to circle these middle two right next to each other, and now they're bonded, but they're not happy yet. So I've still got a lone electron on the top of each of these, and so I'm going to circle those as well. This is called a double bond. So a double bond is when 2 pairs of electrons are shared between the same 2 elements. In our last example, we had 4 single bonds. There were 4 bonds, but they were shared between 4 different atoms. Okay, so you guys are going to work on the covalent bonding worksheet next. So the front is some practice, and then the back you're going to do a bunch of these drawings. So again, make sure that you are putting the most electronegative in the center. You're accounting for all of the valence electrons, and each lone electron you give a partner by circling to show that bonding.